we have a big problem in physics, especially mechanics. For one, it's the pass rates. Like mechanics has way lower pass rates than all the other physics courses. Also, students have a lack of conceptual understanding. If you ask any physics teacher about students, especially mechanics, he will complain about students randomly plugging number into equations, sometimes that have nothing to do with the problem, and then spitting back numbers without really understanding anything that is going on. Now, this is not just an impression of physics teachers. We actually have data for this. Like physics education research looked for decades at mechanics. And one instrument that was used was the force concept inventory, which is a standardized test which tests conceptual understanding. So it has nothing with math in it, all just about the understanding of the Newtonian mechanics. There is 10,000s of test data. Usually this test is given before and after the class, so we have a lot of information here. And I pulled here from one study from Nathaniel Lasry from John Abbott, together with Schmidt and the godfather of physics education research, Eric Mazur, where they did a meta-analysis of a lot of papers that did do this FCI tests to measure how effective the physics course of mechanics is. And what you see here is on the x-axis, you have the students' percentage of correct answers on the first test at the beginning of the semester. And then in purple, you have the fraction of questions that got answered wrong on the first test that then got transformed into a correct answer at the end of the semester. So as one could expect, that students that already started good, they had good improvements. Students that initially had like 20% right or so, they had some improvement. And the thing is linear, as you would expect. However, when you look at how many correct answers on the first test then got converted into wrong answers, that's where it gets interesting. Again, for students that had basically everything right on the first test, nothing bad happened to those. They still got it. Nothing got converted to bad answers or very low fractions. But if you look at the students here that have like medium score at the beginning or lower score at the beginning, it gets bad. In one case here, for 20% students, actually more correct answers got converted into bad answers than good answers got converted, or bad answers got converted into good answers. Meaning for students in that area, taking the class seems to hurt their understanding. They would have been better off not taking the class at all when it comes to their understanding of physics. So basically, Houston, we have a problem, right? Like this should not be happening. Like at least some gains should be there. There shouldn't be losses from our courses. So we do have a problem, which we can document with the low pass rates, but also with all these force concept inventory tests. And now we're looking for explanations. So explanations in the past have been quite varied. Like one of them is directly the problem-solving strategy, the surface approach to problem solving, this crunching the numbers, just looking through the text of the question, taking numbers, putting it in. Maybe if you think about when you self-took the physics classes, that's probably something you did as well. You never either were prompted or converted into actually trying to go beyond plug and placing numbers. This, however, is something that wouldn't really explain why mechanics is different from the other physics classes, because that's present in all of them. And the next one is alternative conceptions. Some call them misconceptions that have to be removed. Me and several others prefer alternative conceptions. Basically, every one of us has some ideas of how physics is working. And some of these ideas are actually interfering with what you're learning in class and counterintuitive if you compare it to, for example, Newtonian mechanics. This one is a very strong candidate to explain what's going on in mechanics, because mechanics is one of these areas where, since you're born, you're interacting with objects in the real world. So you have a lot of built-in conceptions in like 17 years of living on this planet. You know how gravity is, you have some ideas about how gravity works, how objects interact. So then these suddenly conflicting with the Newtonian concepts, that actually might be a reason why mechanics has a bigger problem than the other physics courses. Then we have interference and memory decay, just simply forgetting throughout the semester what you learned at the beginning, or interference. There have been studies, for example, that showed that once you study scalar topics, like, I don't know how far you remember your math and your science, there are scalars and there are vectors, and kind of the world can almost be divided into scalar and vector topics. So that scalar topics can hurt the understanding of vector topics. So first you learn something about vectors, you do fine. Then you learn energy, which is a scalar topic, and everything goes out of the window, you forget. However, this one would also be present in an electricity and magnetism. There we also have a back and forth between those two main worlds. And then last but not least, motivation and attitudes. A lot of students maybe don't have the best attitude towards physics. So that could result in withholding of efforts, especially if the results maybe are not there immediately. So that could all go into the struggle with mechanics. Now, when we learned about a year ago, or was it 2 years ago, we learned about the threshold concept framework. And to me, it was like a big aha effect when we were looking at this, because it just ties in so neatly into this problem. Like, I'm not going to go over the whole framework. You all know about threshold concepts, but here's some of the aspects. Not passing a threshold is known to lead to fragmented knowledge, which, well, maybe that's the reason why people just plug and play with numbers without making connections. Mimicry to cope, reliance on the surface approach. That's exactly what we're observing in mechanics. Remaining stuck in liminality. So basically, you know what doesn't work, but you also don't know what works, which could be actually a main factor here, because a lot of teachers, they put a lot of effort in removing those misconceptions of the students. Like, the students come in with a lot of ideas about how mechanics works. So a lot of teachers put a lot of effort in, let's remove those wrong conceptions so that then we can replace them with the correct ones. Well, the problem might be that you successfully removed what you think they shouldn't use, but there was no success in replacing it with something else. That might be why some students kind of get stuck in liminality. It might be worse on the second force concept inventory test than on the first one. Then just, again, the troublesome nature of the topics discussed in mechanics. They are conflicting a lot with how we experience the world. Then threshold concepts in irreversible nature. Basically, if you learn the threshold concept, things like memory decay should not happen. So if it does happen for a threshold concept, that means you didn't properly cross the threshold. Then problems in learning other concepts. Again, if you didn't master the threshold, you can have problems with other concepts, which could be part of the interference problem we're having. And disengagement, if you frequently hit the threshold, but without passing it, you lose the motivation, you withhold efforts. And here we are in our struggle with mechanics.